Hello friends, I welcome you all to this class. This is mathematics class. In our previous classes, we have been considering this topic, equation of normal and tangent to a given curve. And this topic is under the application of what? Differentiation. So we are considering the application of differentiation, and we are looking at the particular part of application of differentiation, which is the equation of tangent and normal to a given curve. And today we are looking at this third example on this very topic. So let's proceed to what we have on the board here. So they say that they ask us to find the equation of the tangent to the curve y is equal to x raised to power 2 plus 4x minus 3, which is parallel to the line y minus 12x minus 2 equals to 0. So they have told us that the equation of tangent, the tangent line is what? Parallel to the given to this given straight line. Equation of tangent. So let me just write this abbreviation. Equation of tangent will be, the equation of tangent is y is equals to m open bracket x minus x naught plus y naught. So this is the formula for the equation of what? Tangent to a given curve. So I just wrote this abbreviation. Equation of tangent is y equals m open bracket x minus x naught plus y naught. We saw this in our previous class. And this m is what? The slope of the tangent. So this is what you are going to write first. Your work is to get this m, and you must know the points at which you are finding the equation of tangent. But in this question, the point at which you are finding the equation of tangent is not given. But we have little information that the tangent is parallel to this straight line. So we know that the proper way of equation of straight line is what? Y is equals to mx plus c. This is how equation of straight line looks like. So this straight line here, we are going to put it in that form. So we have y minus 12x minus 3 equals 0. This is what is given to us, the line given to us. So if we put it in this form, so this implies that y is equal to, move every other thing to the right, move this to the right, it will change to positive x, move this to the right, change to positive 2. So I put this to this form. So it means if you compare this and this standard equation of a straight line, you find that m here is corresponding to this 12, and this c here is corresponding to this 2. So all we need is m, the slope, because since the tangent is parallel to the straight line, the tangent and the straight line will have the same slope. And from here now, the slope of the straight line is what? M. So implies m equals what? 12. Slope. Right? So the slope is what? Slope is what? 12. From this way we put it. So that we have gotten m for this equation we have here. So what is now remaining is what? X naught and y naught. That is the point you are finding the equation of tangent at. Before you find the equation of tangent, you must know two things: the slope and what? The point. So I have known the slope now, 12, but we don't know the point. But from the slope we can get the point. But m is equals to derivative of y with respect to x at the given point, right? So this will be, which this implies m is equal to, the slope is what? Slope is change in y divided by change in x. That's the y dx. So we'll find the derivative of the curve with respect to x. Well, see the curve here, 2x squared plus 4x minus 3. So we'll differentiate this curve. So if you bring that, what's the power of x here? 2 multiplied to have 4. So 4x, and if you remove 1 from 2, you have what? 1. So if you remove 2 minus 1 is 1. So I have 4x power 1, which is 4x. So if you do the same thing here, if you differentiate 4x here, we'll get what? Positive 4. And if you differentiate negative 3, you are going to get 0 because it's a constant. So this is what we got here. So derivative, our m is what? The slope is change in y over change in s, which is this. So this implies, what is m? 12. This implies that 12 is equals to 4x plus what? 4. So if you move 4 to this side, it implies 12 minus 4 equals what? 4x. Right? If you move this 4 to this side, change to what? Negative. So 12 minus 4 will give you what? 8. Implies 8 is equals to what? 4x. So if you divide this side by 4, that's the coefficient of x. It implies that what? X is equals to what? 2. Right? X is 2. So which means our implies x naught is 2. So the x naught, this point we are considering, x naught is what? 2. Y naught will be equal to, for you to get y naught, you are going to substitute x naught in this equation. That will give you y naught. So if you put x naught for x here, x naught for x here, so y naught will be 2x squared x naught, 2x naught squared plus 4x naught minus 3. So for you to get y naught, you put x naught. That will give you y naught. So, but what is our x naught? We have calculated our x naught to be what? 2. So we are going to substitute x for 2 here. This will be equals to 2 into 2 squared plus 4 into 2 minus 3. So proceeding, 2 squared is what? 4 multiply 2 is 8 plus 4 multiply 2 is 8 minus 3. So this is 16 minus 3, and this is what? 13. So what we got, that y naught is what? 13. 13. That's what we got as the y naught. So we are going to find the equation of tangent now. Equation of tangent. Equation of tangent will be y equals, let's write it here, y equals, what is the slope? See the formula we're using here. We calculated m to be what? Remember, we calculated m to be what? 12. M calculated it to be 12. That's slope. 12, open bracket. Well, x minus x naught. X minus, what is the x naught? We calculated x naught to be what? 2. Plus what? Plus y naught. What is y naught? Calculated y naught to be what? 13. Right, this is what we'll have. So if you simplify, this implies that y is equals to 12 multiply x is what? 12x. And 12 multiply negative 2 is negative 24 plus 13. Right? So what is now remaining is just simplification. So this gives us what? The equation of what? The equation of tangent to the given curve. So this gives us the equation of tangent to the given curve. So thank you so much for this, for being part of this class. I'm expecting you in our upcoming class. Bye.